Okay, this problem asks you to draw the Lewis structure of NH3 and determine all of these properties on the right. If we're in intro chemistry, we're going to stop at polar, nonpolar. If we're in general chemistry, we're going to determine all of these properties. Okay, so if I want to do NH3, what I want to make sure to do is start to count my valence electrons. I've got a nitrogen, so that's 5 valence electrons. I've got 3 hydrogens, so that gets me 3 valence electrons for a total of 8. Now I'll start by drawing the atoms on my paper, try to do it as symmetrically as possible. Now that these are arranged, I will draw a single bond between the central atom and all of the other atoms. So now that I've done that, I would reduce my count by the number of electrons I used. 3 bonds is 6 electrons, and that means I have 2 left. Nitrogen still needs an octet, so I'll do a lone pair on nitrogen to get it its full octet. Remove those from my count as well. I'm down to 0. I've used all of the electrons that I had to draw the structure. I've got octets on everything, so I'm done. Now, in order to figure out the electron geometry, I need to count the number of geometry groups, the number of electron groups around the central atom. A bond in a lone pair counts as 1 electron group. So the number of groups are 1, 2, 3 from the bonds and 1 more from the lone pair. So it's 4 geometry groups. Okay, those geometry groups being 4 leads me to an electron geometry of tetrahedral. Now, the molecular geometry, the geometry of only the bonds, since I've got a tetrahedral electron geometry and 1 lone pair, the molecular geometry is trigonal pyramidal. So again, trigonal pyramidal. Now, we can determine the bond angles from the electron geometry. Tetrahedral electron geometry gives us 109.5 degree bond angles. And with the lone pair there, we can be really specific and we can say less than 109.5. If it's deciding between if it's polar or nonpolar, we would see that all of the bond dipoles do not cancel because of the lone pair. Remember, we can also use a quick and dirty method and just say that with a lone pair, it's going to be polar. If you're in introductory chemistry, that's all you need to do. We can stop there. If you want to go, we need to move on. If we're in general chemistry, listing the intermolecular forces, we should know that everything has dispersion forces. Since it's polar, it'll also have dipole-dipole forces. And because there are nitrogen-hydrogen bonds, remember nitrogen-hydrogen, oxygen-hydrogen, and fluorine-hydrogen bonds lead to hydrogen bonding in a group of molecules. So NH3 also exhibits hydrogen bonding. The hybridization is something else that can be determined based on the electron geometry. The electron geometry is tetrahedral, so the hybridization is sp3. For sigma bonds and pi bonds, remember a single bond is a sigma bond, so we count those up. We get 3 of those. There's no double or triple bonds, so there are no pi bonds. And that's it for us, guys. All right.